Hello and welcome to a brand new episode of It's Not That Simple. And this is a special episode because we're recording it live at the University of Lisbon in the Portuguese capital. We also have a live audience here with us, and I'm delighted to be joined by the Professor Alfonso Martínez Arias. Welcome. Bienvenido.
Thank you, Pedro.
Fantastic to be here. Obviously, all of you know he is a renowned and award-winning developmental biologist. Following many years at the Department of Genetics at the University of Cambridge, he is now at the Department of Biomedical Engineering and Sciences at the Universidade Pompeu Fabra in Barcelona. Also an accomplished author and an expert in the field of genetics overall. It's going to be fantastic to talk about genetics with you, relationship between genes and cells, and we'll really discuss the role that both play in biology and society as well, what we can learn from cells, what we can learn from genes, and offer a cellular-centric perspective on our way of life. So to get the ball rolling, I think it'd be great if you could, in your own words, tell us why genetics is not that simple.
I didn't know that I was coming for an exam. I
I'm just getting started.
I hope you don't have cards, but then you give me numbers and you give me something. I mean, Pedro is being very tough on me.
No way, no way.
Why genetics is not that simple? I think we can turn around the question, and I think genetics is very simple, and that's why it's so successful and it's sold so well. The question is whether genetics is the answer to who we are. I mean, we live in a time where everything is related to a gene or is related to DNA. People talk about the DNA of a football team. People talk about the DNA of a company. People say that they can predict everything about yourself, your health, your longevity, your characters, all from genes. So I think the question that I ask is that that's very simple. You can reduce every single feature of yourself or of your life to a gene or to a set of genes. But is that true? And that's the question. So genetics is simple, but maybe life is not as simple as genetics. And maybe that is the way to put it.
I think it's also very common for us all in conversations to even say, it's not my fault, it's the fault of my genes, for whatever may happen to our life and our health. Obviously, you've turned the table here on this conversation and focused a lot of the work you do on cells. And when you talk about cells and looking at them as the builders of life, what are we able to learn that way?
Well, I think we have to step a moment back and see the ultimate and really what causes me to question the role of genes in our lives, which is when you have to realize that the 20th century is the century of the gene. The gene is discovered at the turn of the 20th century. In 1950s, they discovered the molecular nature of the genes, which is DNA, and now we use it interchangeably. And the century ends with the human genome. It's really amazing that it's bookends to 200 years. And then we are told that the blueprint of a human being is in the genome. Now, what I do for a living is precisely try to understand how an organism is made from a single cell. And then I look for that blueprint in the genome, and I cannot see it. And that's the problem. And as I used to say, because I am in the Department of Genetics, I can say anything I want about genetics. And I think this is the interesting thing, because I think people don't question these things, and we buy constantly that there is a blueprint, and as you've said, that everything about our health, about our life, there are companies that are trying to sell you that. And what I object to that view is that when it makes us feel very determined by our genome, when we look at ourselves from the perspective of ourselves, we are not determined. Something that is very important that many journalists and they say, this person has a gene for this disease. That is not true. We all have the same genes. What you have is a mutation. And it is the cell that has to interpret that mutation. In fact, increasingly we are learning that our body is riddled with mutations. In fact, some of the mutations that are associated with cancer, they appear in many of our cells and nothing happens. Why? Because the cell has the ability to override the genome. Many times. All over. The genes are tools that the cells use to build organisms and to build themselves.
So looking at the cells as the builders of life, what can we learn about our health, about aging, about disease?
I like to think these days that at the moment the same way that I said the 20th century is the century of the gene, the 21st century is the century of the cell. Okay. And it's very early in that path. If you are interested in history, as some of us are, and you look at the first quarter of the 20th century, we were grappling with these entities that were genes. We didn't understand them. In fact, at that time, it's all a bit dark, and people don't understand this. I think we are at a similar time. Look the path that we have come all the way in understanding the genes, and they do have a value. So I would like to see what happens at the turn of the century. Now, with regard to your question, what we don't realize that a lot of the interventions that people have in life, they target cells. They don't target genes, okay? And I feel sometimes that it's like the engineers at the 19th century with the steam engines. They were building steam engines without really understanding the physics of steam. The physicists come later and they make it improve. I think at the moment, a lot of the therapies that are being used for some immunological cancers, a lot of the treatment, they are targeting cells. They are not targeting genes. And in fact, it's becoming very clear to the people working on cancer that targeting genes doesn't work. I think somebody wrote a book whose title I like very much, which is called The Tyranny of the Gene, which explains very well how really what is behind that tyranny that he calls of the gene is a commercial enterprise, because genes create money. And to me, that's a very important thing of genetics. And I don't want to, maybe we'll touch upon some of the developments that are happening in genetics these days. So genetics is simple. Okay. And genetics create money. Therefore, in the world in which we live, they're going to make us believe that we depend on our genes.
In your opinion, how much are we products of DNA versus products of our cellular interaction?
We are not products of DNA. For the biologists in the audience, I mean, with regard to the issue of a blueprint, the issue of the blueprint, it's the only blueprint that exists in a molecule of DNA is another molecule of DNA. That's the only blueprint that is there. The question is, and there is a whole catalog of tools, the instructions to make a human being are not in the DNA. I've looked for them. Now you can say you're just very dumb and you don't know how to find them. Okay, that is possible. I mean, after all, I'm old. It's the young people, but I can tell you, I try very hard to find them. Okay, and I think this is the thing. And now people say when they argue with me because they are getting tired that I tell them that it's not in the genes. They say, oh, well, we know that, and then they will go on and keep on talking about genes. Because it's easier, you see, it's much easier. I think there is something very exciting happening. There is a small group of people that are starting. You've talked before about the language of the cells. We don't understand that language. We don't speak it very well. We might come back to that, and I'll explain what I mean, but we don't speak that language. Trying to talk to them, they don't understand us because we don't speak that language yet.
Well, I did want to ask you about that and cellular interaction and cellular cooperation as well, because we depend so much on that. Are there examples in everyday life, examples in medicine that best illustrate this communication or this cooperation between cells in our bodies?
Well, I think a bone marrow transplant to cure that, you're changing cells, you're not changing genes there. And the cells are cooperating. You wipe out all the bad cells with irradiation, and then you put good cells. You don't put good genes. No. In fact, people are realizing that it's very difficult, this targeting of specific genes with these genetic scissors that they call CRISPR, that many people know about, even if we don't know what the acronym means, we get very excited. But the number of diseases that can be repaired with this CRISPR is really, really small. Apart from the small issue that it costs $3 million a shot, okay? But that's minor, okay? Because it's the people that are making the money with that. And it's much easier. If we could create the stem cells, the original cells of the blood, it would be a much more effective repair. CAR T cells, this is a very famous treatment these days which helps repair a lot of immunological and cancers. You are dealing with a cell. You're giving it a new tool. But it's the cell that is interpreting what you are putting there and using it to search and kill the tumor cells. So we are dealing with cells. It's a bit like building these steam engines in the 1860s. When we understand what we are doing, it's going to be incredible.
So how much do we understand about the way that cells, or starting with a single cell, builds an organism, knows where to place the heart, the fingers, the legs, and create an organism from the initial cell? What do we know about that, and how much have you looked into that particularly?
Those that know me know that I'm a black and white person because it's the only way to get people to listen to you. If you say it's complicated or I don't know, we don't know anything, okay? Let's just take it like that. Maybe I'm giving a living here to a lot of people in the audience, okay? You're not going to make a living studying genes in 20 years, but you're going to make a living studying cells. But actually, there is some truth into this because our interpretation of how a cell becomes many, how they become different, how they organize in a space, is based on what people call a genetic program. Because it's been made over the last 40 years. We've created this illusion that we are made in your genes. But I don't see that. There is no way. It is the cells. The minute there are two cells, the minute the first cell divides to generate two cells, they start talking to each other. And they start using the genes as tools. Okay? And I think we have to separate the design from the tools. Right? I mean, when you buy an IKEA, we all struggle with these IKEA kits, you know. I mean, the design is not the tools. And you give given the wrong tools or the wrong pieces, and you're going to get something like many of us do that has nothing to do with what is in the booklet.
In the instructions, yeah.
And I think this is the genes are just the screws and the boards and how the cells have those instructions, we still don't know. And I can give you later very interesting examples that will prove my point.
So how do cells interpret the DNA? And why is that interpretation more important than the coding itself?
Because the coding is just what is in the coding is information to generate tools. Tools are proteins. They are RNA for those, but proteins is something that we all understand. So all of a sudden you find yourselves, I mean, what somebody digging inside the cell would find out of the DNA is hammers, screws, wrenches. That's what they will find. That's all the DNA. Now, you need some kind of a plan to get to understand that. And we still don't understand. What we know, what is becoming clear, and that's becoming very important to me, is that we've learned a lot of cell biology, what people call cell biology. That's the biology of one cell. The minute we start putting together, and I have this argument with some of my colleagues, the minute you have 3 or 4 cells together, things start happening that we haven't seen before. And this is something that our work has revealed, and that we don't understand. We cannot even define them at the moment, and that's going to be very, very important. Whether the cells know how to count. We know that. During development, the embryo starts dividing, it forms a mass of cells. At a certain size, they start doing interesting things. But at a certain size, when there is a certain number, how do cells know how to count? That's not in the DNA. Your cells in your body are turning over. The cells you get a new stomach every week, a new skin every month, a new skeleton every 10 years, which excites me very much because when my jacket doesn't fit, it's not that I'm gaining weight; it's my skeleton has changed. Okay, remember that one. All right. You can do that. Don't be telling every 10 years. Where are those numbers written? Where are those numbers written? How do the cells know? That's not in the genes. So there are very big questions that I think sometimes they are being shunted, they are being shished by this emphasis that we can always find a gene that is related to something. I think as a scientist, and I think Maria has expressed it very well, we are meant to question reality. And I think today it looks sometimes that we are not allowed to question because we know everything. We can always find a gene. And it's a pity for the young people because there is something exciting and new. It will come true. Science always works like that.
Yeah, well, it's never easy to go against the establishment, especially, as you mentioned, if the establishment has financial gains involved as well. I wanted to talk to you specifically about stem cells and gastruloids, which you can also define. But how do they change the way we treat congenital defects, in your opinion?
To understand congenital defects, first we need to have models. I mean, to work with humans is very, very difficult with human embryos. Congenital defects mean abnormalities or syndromes that appear during our development in the womb.
No.
And it's very difficult. It's impossible. We cannot do experiments. So I'm not going to bore you with my life. I mean, I can do it in private if you're interested. But at a certain point, I was always curious about these stem cells. If you allow me 3 minutes, I'll tell because it's important. And I was always very curious when I learned about them that these embryonic stem cells are the ones that keep your stomach going, your skin going. They're renewing at a pace that we don't understand. Why? Because it's different in every part of your body. But these embryonic stem cells were very remarkable. They were extracted from early embryos. They were in the dish. And then every time you put them into a mouse, they will make a mouse. But in the dish, they would never make a mouse. I found that very, very strange. I am happy to entertain. I was brought up Catholic, so I'm very, very, very agreeable to the possibility that there is a reality that we don't understand. But as a scientist, I do like to question that reality. So we set up to try to see why these cells were not making a mouse embryo in the first place. There is this process which a good friend of many people in the audience called Louis Wolper used to say, it's the most important moment in your life. It's not marriage, it's not birth, it's not death, it's gastrulation. And I'm very surprised that many people in this audience will have heard of CRISPR, it's very difficult, and they don't know anything about gastrulation. Which, if you think that it has to do with food, it does, because gastrulation is a term that was invented because the first thing that forms in any organism is the gut. And the person that don't have gastrulation is the magic process whereby the cells that have resulted from increasing the cell numbers, the cells have to generate space first. Okay, the cells, because you get one cell, but you need many in order to. And then this magic process of gastrulation, you can find movies of it in the web. It starts, there is a choreography, it's like a ballet. In fact, you can put music to it and you'll be besotted by it. And then the cells start moving, and all of a sudden, magically in a week, the body of an organism appears there. So this gastrulation process is crucial to everything that we do. Now, we all of a sudden found that we could mimic this process in the dish. And that out of what was a mass of cells, all of a sudden this structure that resembled a mouse embryo appeared. But what's interesting is that would only happen if we put a certain number of cells. If we went above or below, above it would make a mess, below, the cells in the dish could do interesting things, but only when they were the right number. So you're asking me, that raises amazing questions that we are very, very interested in, all right? So that's what we call a gastrulate. The reason is that you have to make a living. So you have to invent a word so that you can sell what you do and make money out of it, okay? So don't think that there is anything deep in that. So that's what it is. How is this going to change? Because then we realize if this happens in the mouse, we can do it in a human, with human cells. And we did. And the results have been very, very surprising. There are many surprising things about these gastrulates with human and with mouse. And all of a sudden, we have a way to study early human development, the origin of disease, without the need of human embryos. Of course, this poses a number of very interesting questions about what is an embryo. Are we creating life, as many people will say? And I won't bore you with that, but I'll be happy to answer questions here or later. But this is very new. There is a number of us that are making this what we call models. But it's very exciting because all of a sudden we can recreate these structures that mimic in many ways what human embryos are. And for the first time, we have the access to a part of our life, although whether it's our life or its life is something to be debated that we couldn't have before.
In your opinion, and taking into account all the work that you've done, all the research you've conducted, what does this tell us about the origin of life? When is the origin of life? And you touched on it there, and what do we still not understand about where the origin is?
Big words, huh? The origin of life.
Life.
I think he means the origin of human life.
I do.
Okay, you see?
I do.
I'm used. Because the origin of life, I find the origin of life, and I've been criticized for what I'm going to say, the most boring question in biology. And the reason is that we cannot do any experiment to tell us how it happened, okay? It can have happened in many ways. If somebody, and Francis Crick, the famous biologist, used to believe that, if you tell me that it came from outer space, that's fine with me. Now, when life starts is when you make a cell.
Right.
When the cell was invented, as my friend Louis Wolper used to say, it's downhill from there. And then the question is, how do you go from organisms, and most of the Earth is populated by organisms that are one cell, to multicellular organisms? Because that's what's happening during development, and that's a big question. Is it the tools? Is it that you get more tools? Or is it phenomena that the cells discover that they can talk to each other using the tools in different ways that they talk to each other when they are single cells? We don't know, but that's a fascinating question. Human life, that's a totally different, that's a question where we would have to talk, and maybe we do, about ethics, religion, moral, philosophy.
Yeah, I'm sure you've had many conflicts being raised Catholic and taking into account a lot of the research that you've done. But when it comes to cellular growth, cellular cooperation, cellular interaction, and I wanted to talk to you about cellular autonomy and how that can change our perception of what individuality is.
There are many organisms that are one cell. Okay? I think the big jump, the origin of animals and plants, is when cells start cooperating and building things together using genes. Because now we are learning that a lot of the genes that we thought were only associated with animals, there is a big jump in the people thought that there was a big jump in the parts list, in the tool list, in the toolkit. But now we know that a lot of the genes that animals, particularly animals, use to build multicellular organisms, they are already in things. So people thought for a while that it would just have been an increase in the toolbox. Now we know that that's not the case. So we need to understand how do cells in our experiment know to count and to react to. We are starting to see that this is so. Multicellular life is about cooperation. In fact, recent experiments that I don't want to bore you with are proving that not only you need many cells, particularly there, but they have to be slightly different from each other. If you try to make an organism from cells that are all the same, it will not work. This is part of the work that we are doing with these gastrocs. So you need a certain heterogeneity, a certain differences. And I think that's very, I mean, to me, that's what it says is that cooperation, interactions are creative. And I think, maybe you're going to get into that, genes give you a selfish view of life that comes from, cells give you a cooperative and altruistic view of life.
That's exactly actually the perfect link into a couple of questions that I had about comparisons that you've started to make between the human organism or organisms overall and the relationship that cells have towards the creation and cooperation inside a body, inside an organism, to the way that a selfish gene has been described. And you had a very interesting article in El País, which I had an opportunity to read, where you start making comparisons between the work that you've had in your biological field to the society that we live in. I think it'd be fair to say that nowadays, the more divisive, the more polarizing that politicians are, the better results they're having. We live in a society that is more about me and I rather than we. And this is a little bit propagated, and of course what matters is your opinion, but it's a little bit propagated by the selfish gene conversation. So I wanted to talk to you about that first before I get into the cells, and how rhetoric is being used, and the selfish rhetoric is being used around genes to justify certain kinds of behavior and individuality and selfishness.
I think sometimes we don't realize how science impinges in our lives indirectly, because people take slogans or ideas. And for example, Darwin, of course, the survival of the fittest was very important socially, and it led to a lot of issues and problems. And for some of you know, World War I is triggered by an application of Darwinian theory. In the 1970s, Richard Dawkins published this amazing book, which had an effect in many of us, called The Selfish Gene. And that has really taken on a lot of views. I mean, Margaret Thatcher in the UK started to talk about there is no such a thing as society, there is the individual. And that was absolutely bred in the notion of the selfish gene, because for Dawkins, we are just machines that are built by genes to propagate themselves. And in fact, genes are individually struggling with each other to propagate society, and there are good genes and bad genes, and Dawkins talks about this. Now, if you follow the politics in the United States a little bit, they are talking about good genes and bad genes. The immigrants are bad genes, the wasps are good genes. So all of a sudden, we find ourselves that we are justifying. I mean, you may have heard in certain places this theory of replacement theory, which means that there are bad genes that are taken over our society, and therefore we have to breed in different ways to exclude the bad. So all of a sudden, in biology, this idea of genetics takes, without us realizing, a social impact that can be. So they are using biology to justify what is basically a social agenda. and they tell you it's because of the biology. And I think this is very dangerous. But that's where what we were talking at the beginning about the fact that genetics is simple to explain to people. And if you talk about good genes and bad genes, it doesn't matter that you're, what are the good genes and what the, no, they can't say that, but people don't want to understand. They want to buy this relationship between us and the genes. So I do think that is a very good example and today, as I say, it is being used in the States, this idea of good genes. I was very disappointed that Dawkins in his last book talks again about good genes and bad genes. I think in order to understand the problem of Dawkins, and you know, of course he's not here. I'd love him to be here, by the way. If you want to bring him, I'll take him on. Whether he wants to take me on is a different matter, okay? But I'm sure he does, because he doesn't think very much of me. He doesn't know me. But I think that the problem, he's what we call a behavioral ecologist. He makes a big jump from the genes to the behavior of parasites, to the behavior of he thinks that this is written, and he's very clever, he's very articulate, he's British, and they're very good at that. But he doesn't know anything about cells. Every time he tried to talk about development or about cells, the whole collapse fast, because what is between the gene and the behavior? There is the nervous system, there is a body, and who builds that? All right? So this is to me that I didn't want to dive into the cell. So you don't realize, but these ideas of genetics are impinging not only in your health, but also in society in a very devious and pervasive manner.
Why did you decide to look more into how biology can inform our understanding of society as well? Because it is incredibly interesting if we go back and look at the dynamics of society and between human beings where, and I think you believe this, that we are like cells in an organism that is the planet, and we should be working together to preserve the planet, whereas that is clearly not happening, and the behavior is increasingly individualistic. Do you see it as a responsibility, taking into account what you have seen as part of our organism, to use it as an example for society?
I think you've put it very well about our planet being the cell. At the end of the 19th century, before we, by the way, although I look old, I wasn't born in the 19th century, okay? But I think that at the end of the 19th century, because we didn't know the genes, people explained a lot of in terms of tissues. Very famous biologist called Rudolf Virchow. I'm very tempted, and I will tell you a very interesting anecdote about him. He was very socialist. He was working in Germany. He is really the father of the theory of cancer and the cell. And he talked about the body as a cell state, in the sense, not in the cell state that we use in biology, but about state, a political state made up of cells, in which all coordinate. It's very interesting to read him. He was a very interesting person. And he thought that cancer, because this is something he was interested in, was a position in which the state broke down. Because the interactions between cells that he was... So that is quite interesting. If you allow me a very quick anecdote about Virchow, he was a socialist, and he was very vocal, and he upset Bismarck, the chancellor. So Bismarck challenged him to a duel. And because he had been challenged, he could choose the weapons. He chose a sausage. You can look at this in the web if you don't believe me. But he said there will be 2 sausages on the table. One will be full of a parasite that will kill you. The other is not, and you have to choose which of the sausages you take. Never make a bet with a biologist that wears your life, okay? But Virchow talked about the cell state, okay? So this idea, but then the gene wipes all these theories. And yes, I would be interested in, and I'm very keen on the same way. Of course, I'm not at the same level, but the same way that Dawkins popularized this idea of selfish genes. I think we have to start looking at how cells work and the fact that through those interactions they create the beauty of an orchid, of a rose, of a butterfly, of us. Because that's what cooperation does. Maybe this is a drop of water in the ocean, but I do think that we need to try to look at biology in a different way that we have been looking from the perspective of genes.
How difficult is it to shift these views, these perspectives in the medical field, in the scientist field, when it comes to shifting over the focus to cells? And you mentioned how the next century will this century will perhaps be more dedicated to the study of cells rather than genes. How difficult is it to make that shift, and what do you think the path is? Do you see a responsibility into leading that path?
Well, I think I don't have to tell you and this audience that we live in times where the noise is about the signal. I mean, this is a big problem. I sometimes think that there is 2 or 3 parallel worlds going on. You know, one is this noisy one. Right. I think medics, biologists continue to make efforts in parallel, and as I've said before, many therapies that are being used, they are using cells without maybe understanding or realizing that we are doing that. There is many problems, many situations which we are blaming the genes for. Perhaps if in a conscious manner, because it's easy, if we could develop, and I'm very sure that in the next 10 or 20 years we're going to start understanding these properties of groups of cells that are very new and that are going to change the way we treat diseases. When I talk to people that work on the drug field, not on the drugs, but on the drugs, right. They tell me that the drugs that are often more effective are what they call dirty drugs. That is to say, those that you don't know the target of completely, that they can target a lot of things, and those are the most effective ones. The more you target something, and this is where the gene, the tyranny of the gene comes, because a lot of the cancer, they focus on a gene, they develop these very specific inhibitors, they do. What do? You extend the life of a person for a few months, but you don't solve the problem. In fact, a lot of the cancer field is now realizing that it all has to do with what they call the cell of origin, not the gene of origin. And we would like to understand that. I think they are exciting times for the young people, because I think we have a lot of, and that's, as Maria has said, that's what science is about. There is lots that we don't know. That's what has moved me, her, and many people in the audience. Not in the genes. And cells are us, by the way.
What do you hope will be the biggest development in the study of cells in the next decade? And what role does technology play?
I think it's happening already. Many of you will have heard these organoids. I mean, we are working at the end of the embryonic development, but these days people can mimic your gut. They can mimic it in the lab. And there have been, this is what is called intestinal organoids, and there have been very remarkable examples. We are learning that cells have this ability to recreate autonomously, not as single cells, but as groups, that we are a collection of entities. The same way that an organ is a collection of cells, we are a collection of organs that are cooperating, but we can recreate in the lab the organs individually. And in this case of the intestinal organoids, which are made from adult stem cells, the ones that are regenerating your intestine, they've been experiments in which they've done it with cancer patients, and they try the same treatment in the patient or in the organoid, and it works. Therefore, all of a sudden, it opens a tremendous possibilities of testing a lot of therapies in the organoid, in the, if you wish, and people use that term, the intestinal avatar of the person, and then only use the ones that your avatar, your intestinal avatar, reacts to a thing. We are working at the other end in the very early stages of development, and we are learning a huge amount because, for example, many people will not know it, but only 1/3 of the conceptions make it to term. 2/3 of the conception disappear before the 3rd week of development. And that's a very human thing. Monkeys don't have this problem. So we need to understand this, because I don't have to tell you the emotional cost of all that for the people. That happens in IVF and in normal pregnancies. So I think our models are going to help us, and there are many people developing on it, all these things. So this perspective of creating these models that we are doing, not because we are tinkering with genes, but because we are tinkering with cells, are going to create a new kind of medicine, which, if you wish, we can coin a term here, it will be cellular medicine.
Okay. As we get ready to close our conversation, and before we go to the quick fire round that we always have for all of our guests.
They hadn't told me that.
It's a surprise.
I hope he doesn't get a gun out.
No way. We talked a little bit about technology, and nowadays it's difficult to have any kind of conversation without mentioning artificial intelligence. How much do you think scientists will benefit from this technology, and how important is it to keep a human element in the future when it comes to the work that will be done with cells and cellular interaction?
Most people that use artificial intelligence don't realize that they are the boss. They're running the thing. I think we have a choice: either succumb to artificial intelligence, and that's what the fear, or continue to control it. I think it can be extremely useful
as a tool.
As a tool. I absolutely agree. These days, people talk about the virtual self. They like to create. That's not going to be possible. Okay. I think we still don't know these properties that I've told you, because we don't. And the reason, the people that, when you read these people that are very famous, very important, they have a lot of money, what they want to do is build a self from the genes, because that is what we have. That will never happen. That will never happen. In fact, if you go to the origin of life, I think for a moment I'm going to allow myself to speculate. People spend all the time, how was DNA invented? How was metabolism invented? But the container of all that, that's the cell. It's the membrane. You cannot expect these things that are rolling around in mud or in water all of a sudden to build the membrane. I think there was the membrane forming around, and then a cooperation between these three things: the DNA, the energy, and the membrane. They form something. Always cooperation. In the origin of biology, there is always cooperation. There is no selfishness. So I think the virtual cell will never, I mean, we think we understand genes, but with understanding genes, we understand very little. People are trying to use AI to build, but a cell is something, I don't want to sound mystical, but I will say that we still don't understand. I could tell you endless fascinating stories about what cells can do. And just think about a neuron. A neuron is a highly interesting machine. I think AI is an aid, is a tool, and we should learn to use it. We should not allow ourselves to be used by it.
And we also need to regulate it somehow. Don't know
absolutely,
how
absolutely.
Easy that will be.
That was not a quick fire answer. Apologies.
No, but we're just going to start the quick fire now. That was the last.
That was a prelude.
Interview, yeah.
Okay.
The normal interview
Ready.
session. Now we have the no gun quick fire. Starting with what is the most. So in one sentence, that's the model. Okay, in one sentence you have to.
German sentence or English sentence?
Let's
Which
go.
one you want?
You pick the kind of sentence you want. If you were going to summarize the most important learning of your life and career so far, what would it be?
Help people and be helped by people. Cooperate.
What is one character trait a good leader could benefit from having?
Compassion.
That comes up a lot, because I don't think we see a lot of it these days.
Empathy, compassion.
Yeah. What is the biggest challenge, the biggest threat to our way of life, to our planet at the moment?
Our selfishness. I'm giving you very British answers, right?
Yeah, very. Very.
I can switch to German anytime.
And if you could change one thing by magic on the planet, on the universe, what would that be?
The future of young people.
And how would you change it?
I don't know. You haven't, I mean, but I think we have to become aware that is a problem. And I think we are, and start looking for solutions. I hear a lot of the problem being defined and very few solutions coming. And I'm particularly and personally invested in that. I mean, I always tell students that if they are really good scientists, you work locally, but think globally. You have to think of a very specific question, but that relates to a big question that you have. So in this issue, I think we need to not try to solve all the problems of all the young people, but work on small things. Sometimes your community, if you are a teacher, the people that you work with in the class, and hope that permeates. I always say that the most important thing I've done in my life is teaching. And if in a class, a course, I've changed the life of one or two people, that has been enough. Yeah. And I think that's how we're going to do it, with patience and becoming aware of it, that when you are dealing with people, you are dealing with the future of those people.
Professor Alfonso Martínez Arias, it's been an absolute pleasure to have an opportunity to share this stage here with you. Thank you for your insight. Thank you for your expertise. Thanks for your humor as well, which helped the conversation. And I would like to thank for a big round of applause for our star guest here today.